evening. It's my pleasure to be here again with you tonight. As you probably know, tonight is day 5. This is like our halfway mark of the series. So, for those of you who have been here for the last 5 days in a row, or have joined us somewhere, after the first day, thank you for your persistence, in continuing to come. This evening, I'm going to talk about the rhythms of life. And, this is a fascinating topic to me and, to many scientists who study this particular subject. Our bodies have clear, distinct rhythms that we should know about, because what we want to do is, for good health, we want to keep in sync, to match these rhythms. You don't really want to go against the rhythms of your body, because if you continue to do that, that can actually cause problems and lead to disease and poor health. So this evening, I wanted to talk a little bit about circadian rhythms. You may have heard of circadian rhythms, and then also a less well-known type of rhythm called circaseptan rhythms. And I'll talk about those at the end of this presentation. And my title here at the beginning says chronobiology. And as you probably can guess, chrono refers to time, right? There's chronometers, that measure time, and then biology refers to life, right? So there is a rhythm to life in human beings and, also in the animal kingdom as well that we should be aware of. So we all know that Albert Einstein was a very, very intelligent man, and he said some very intelligent things. And this is one of the quotes that is attributed to him. Some people say he didn't really say this. Some people say he said this, but we won't know because he's not alive today. But it's said that he said, "The only reason for time is so that everything doesn't happen at once." So I don't know if that's true, but there is a reason for time, and there is a reason that we measure time. So what rhythms govern the human body? So the most well-known are circadian rhythms. So the word circadian is kind of a combination of two Latin words. One is circa. Circa means approximately. We still use this Latin word today in English. So if you say circa something, it means approximately or around a certain time. And then dies means day. So, approximate time. So these refer to daily rhythms in human beings, and again, in the animal and plant kingdom as well. So 24-hour rhythms. And then we have rhythms that are shorter than 24 hours, and we have rhythms that are longer than 24 hours. So the ones that are longer are called infraradian, and then the ones that are shorter than 24 hours are called ultraradian. And then, as I mentioned earlier, lastly, we're going to talk about circaseptan rhythms. And circa, again, means approximately. Septan actually refers to the number 7. So there are also 7-day rhythms that have been discovered in human beings and in nature and in music. So we'll talk about that too briefly. So let's look at circadian rhythms first, the most commonly and well-known rhythms. So frequently we also call these diurnal rhythms. They have a 24-hour kind of oscillation pattern. And to actually be a true circadian rhythm, there are a few characteristics that we need to know about. So one is, it has to be endogenous, meaning it's not because, you set up a schedule of 24 hours, externally. It's internal. It's like an internal clock. And so these are endogenous rhythms. All right. Second is that these rhythms, these circadian rhythms, can be entrained. Now, what that means is, and I'm actually a good kind of human example of this right now. So we have one of our most famous circadian rhythms is the sleep-wake cycle, right? You sleep during the day, or you sleep at night, and you are awake during the day, right? So your sleep-wake cycle. And sometimes this is disturbed by certain processes. For example, if you are working during the day, and let's say your boss comes to you and says, you know what, we really need you to work night shift, because, we don't have enough people for the nighttime. So you say, okay, and then you've been working days, and suddenly you have to, instead of sleeping, you have to be awake at nighttime. So, normally our body is not used to that, but it can be trained so that, you can stay awake at nighttime. So that's what we mean by entrainable. It means that you can reset your rhythms too. Now, I will say that can come at a cost too. And I say that I'm a human example of that right now because right now I do have some jet lag, So I calculated, or I looked online and I saw that Bacolod is about 15 hours ahead of California. So for me, my body is, I think, still 15 hours behind right now. And so I noticed how this is affecting me. I'm awake and I'm speaking, but one of the things I noticed in the last few days is I'm forgetting things like items in different places. And normally I'm not that forgetful, but I keep leaving things in places. And I think part of this is my jet lag. It's affecting my memory a little bit. So hopefully I will adjust. But the good thing is your body is adaptable. It can be entrained. One way you can think of it is it can be retrained. And then lastly, circadian rhythms tend to stay stable even with some temperature variability. So in other words, let's say the weather is cold or the weather is very hot, your circadian rhythms should generally still, continue to perform the way that they have, even with temperature changes. Now, I know this slide, some of the words are a little bit hard to see. I was trying to make this larger, but it was difficult. But basically, it's well known that, for a human being who kind of follows a normal schedule, again, meaning that you're awake in the daytime and sleeping at nighttime, there is a very predictable pattern to certain things that happen in the human body. So this is actually illustrating a 24-hour cycle. So, your normal clock usually shows 12 hours. So this is showing 24 hours. But I'll just point out a few things that, again, are very predictable. So one of them is, let's see. Did you know that for human beings, your deepest sleep occurs at about 2 a.m.? So if you go to sleep at a normal time, your deepest sleep should occur at about 2 a.m. This is relatively predictable. Now, if you stay up late and you go to, you climb into bed at 2 a.m., this will not be your deepest sleep. But let's say you go to bed at 9 or 10 p.m., your deepest sleep should be at about 2 a.m. Again, for most people, with few exceptions, your lowest body temperature is at 4:30 a.m. So this is a little bit before you wake up in the morning. And again, this is quite predictable. Let's see. Your highest body temperature during the day is about 6:30, is about 7 p.m. is when your body temperature is the highest. So that should be in about 20 minutes that you should have your highest body temperature for the day. And then at about 6:30 p.m., you should have your highest blood pressure, so they say. So these are just a few examples of the fact that your body has very predictable rhythms. If we were to, put it on a piece of paper, it's very similar for most people. So I find this very fascinating. They also say here, this is interesting, at 2:30 p.m., you have your best coordination. So sometimes they say, if you want to exercise and do some kind of especially complicated exercise, you might do it at, in the afternoon. Okay, so again, this is just kind of in a graph form, an illustration again that, you really have a distinctive pattern to many of the functions of your body. Again, I know this is a little bit small. If you look at the very bottom, so the bottom is body temperature. So you can see that this is actually showing a 48-hour period. You see at the top 6 a.m. to 6 a.m. and then to 6 a.m. again. So it's 2 days actually. So you can see that you have very predictable patterns to body temperature. And the one above that is melatonin levels. We're going to talk about melatonin levels very soon. Melatonin is the hormone that your body produces for sleep. It's known as the sleep hormone. Now this is another illustration. It's just showing, again, very predictable pattern, this time of certain parts of your kidney function. And I won't go into too much detail, but again, you have very predictable patterns of how your kidneys function, again, in a normal human being with a normal, schedule. So there are so many human bodily functions that are governed by circadian rhythms. And these are just a few examples. So as we mentioned earlier, blood pressure follows a circadian rhythm. Many of the hormone levels in your body follow a distinct rhythm, and brain activity, all these types of things actually follow very predictable rhythms. And this is a good thing. So you may be thinking, okay, so how does the body know to follow rhythms? How does it know? Like, is there a little clock somewhere in your body that governs all of these rhythms? And the answer is yes. So you do have a clock. You have a master clock, as you might guess, in your brain. It's a very small area of the brain. It's about the size of 1 grain of rice. So it's very small, but it's very important. If for some reason this part of your brain were to be damaged, you could have major problems with these circadian rhythms. So this master clock in your brain that controls circadian rhythms is called the suprachiasmatic nucleus, the SCN. And I'm going to show you, where it's located. We're going to look at a little diagram of the brain. But it's located in a very important area of the brain. Again, it's very small, this area, but it's called the hypothalamus. And the way that this clock works is it receives input signals through your retina. And your retina is a part of your eye. And then it travels to this small part of the brain called the hypothalamus. And then to an even smaller part of the brain, this SCN. And that helps your body to make sure the clock is set properly. So each day, actually, the clock resets. Let's say you have an unusual day. Maybe you wake up very early, or you wake up late, or you didn't sleep well. Your body adjusts to this too, and it can reset the clock, a little bit. So the SCN interprets this information, and it also sends this information to another part of your brain called the pineal gland. Pineal gland is responsible for melatonin secretion. Just like we said earlier, melatonin is the sleep hormone of the body. And so, this helps you regulate your sleep and wake cycle. Now, you don't only have one master clock in your body. You have one master clock, I should say, but you have other clocks too, believe it or not, that control rhythms in your body. You actually have clocks in your liver, in your kidneys, and in your intestines, just to name a few places. And so it's quite amazing. You have the master clock, and then you have these kind of smaller clocks scattered in organs throughout your body. So here's a picture, a diagram of how this happens. So one of the key triggers for your body setting your circadian rhythms and making sure it's correct is light, specifically sunlight. So if you get, your normal amounts of sunlight, the sunlight comes in and you perceive it, of course, through your eyes, and the back of your retina. This is part of your eye, and then it goes to this little area in your brain called the hypothalamus, and then even smaller area in there called the SCN, the suprachiasmatic nucleus. And then that sends signals to your pineal gland, which produces melatonin, again, the sleep hormone. So this is one way your master clock in your body sets itself. Now you all know, probably from some experience you've had where you have not slept enough, that not sleeping enough is bad, right? If you don't sleep enough, you feel tired. Sometimes if it's really bad, you can feel disoriented. You can be like, what day is today? What am I doing? What am I supposed to do today? Your memory can be affected. You can become grouchy and unhappy. So many things can be affected by lack of sleep. And this list just shows a few of them. But you can have, as it says here, fluctuations in your mood. You can become depressed if it goes on long enough, irritable. Your attention may not be as good if you don't get enough sleep. And then, if you have these kind of problems long term, they unfortunately can contribute to some major diseases like diabetes, cancer, heart disease, and also problems with your immune system. You've probably noticed that if you don't sleep enough, you are more susceptible to getting sick, to getting colds and infections that you normally would not get if you have enough sleep. So this is just, again, to illustrate that you have your major master clock here on the left side, the SCN, and then you have other smaller clocks in some of the organs in your body. Now, in the science of sleep and circadian rhythms, there is a certain word, and it's actually a German word because I think the researcher that discovered this and described it was German. And so he used a German word. This German word is Zeitgeber, or Zeitgeber, I should say. So if anyone studied German here, I studied German briefly in high school, but Zeit means time, and then Geber means to give. So time giver. So, one of the ways, in addition to sunlight and light, that our body readjusts our circadian rhythms and clocks is it looks for Zeitgebers, like clues in the environment and in the way we live our life. So there are many Zeitgebers, these clues and cues that help us to readjust and synchronize the body clocks in our body. So some of them include things like eating, like when you eat is very important. So, one of the things is if you can eat at regular times every day, this is a benefit to your circadian clock. If you eat at all different times all the time, you eat very late one day and then you eat very early another day, and it's very inconsistent. This is not helpful to your body's clocks, So a regular lifestyle is very helpful to maintain good health and to help your, these clocks and these rhythms in your body to help you stay healthy. Another Zeitgeber, another clue or cue for your body is your social interactions. So many of us go to school or to work, or we go to visit our friends or family. And obviously we do that when we're awake, right? We don't really do that when we're sleeping. So social interactions also give very good cues and clues to our body that, this is the time for us to stay awake. So again, if you are staying awake late, very late at night, not getting enough sleep to talk to people, etc., then this also disrupts your body's circadian rhythms. So a lot of these cues and clues we should be, I think, more conscious of because we need to help our body's clocks stay on time. Now, this is another kind of busy illustration with lots of words, but that's basically what it's saying. On the left side is when, you live your life in sync, in the same rhythm as your normal body clocks. You will be helping your overall health. You'll have good synchrony and health. But if everything is out of sync and messed up, this will lead to the increased risk for disease and what we call dyssynchrony. Now, I don't know how many of you have an interest in art, But I think you may recognize this painting. How many of you recognize this painting? Does this look familiar to you? This is kind of a very famous painting in the art world. And this painting is by a painter named Salvador Dali. It was actually painted in 1931. And this is called The Persistence of Memory. Now, I am not an art expert or anything near that, but in this illustration, when I was looking at this the other day, I just thought, wow, this is kind of a great illustration for what happens when our bodies, are not in sync with the clocks in our bodies. These endogenous internal clocks that God has made for us to promote good health. When we are not synchronized with them, this is kind of what happens. Here you have a variety of clocks, and there's something wrong with them, right? They all look like they're not working properly, right? And it looks like they may all be at different times. They look out of order. And so I don't know I'm sure the artist had other meanings besides this, but when I saw this, I was like, wow, this is a great illustration of dyssynchrony and what should not happen with our circadian rhythms. So let's look at one of the major circadian rhythms, the sleep-wake cycle. So all of us, are part of the, we need to have the sleep-wake cycle. There is no one that I know of on the earth that does not need sleep. Everybody needs sleep, right? There's no exceptions to this that I know of. It is true that some people say they need less sleep, but so there is some variation in that, but everybody needs some sleep. And so there's so many factors that affect the sleep-wake cycle, and just some of them are listed here. But you can see among them we've been talking about melatonin levels, even temperature. So when it's too hot, it's hard to sleep, right? Or even if it's too cold, it's hard to sleep. So there is an ideal temperature even for sleeping. Social factors, behavioral factors. If you just had a fight with someone, it's hard to sleep, right? Because you're all upset and mad. So there's so many factors that affect the sleep-wake cycle. So let's look briefly at the actual sleep cycle itself. So there are 5 stages of sleep. And you may have seen some of this before. When you first fall asleep, you have your very light sleep. This is when it's very easy to wake you up. But as time goes on, you go into deeper and deeper levels of sleep. The deepest level of sleep is stage 4. And this is characterized by, if we measure your brainwave activity, you would see something called delta waves. And delta waves show that you are in your deepest amount of sleep. And then stage 5 is called REM sleep, which stands for rapid eye movement. This is generally the sleep for when you dream. And, honestly, I don't remember most of my dreams. I don't know if you remember most. I don't remember most of them. But, most of us do dream, even if we don't remember our dreams. And REM sleep is when you have dreams. Now, when we go through these stages of sleep, we don't go through them just once while we're sleeping. This little pie chart illustrates that you go through these stages multiple times throughout the night. So you can see that the gray areas are considered deep sleep. So you can see that you keep going in and out of deep sleep throughout the night. And you notice that the red areas are REM sleep. This is the dream sleep. So, you'll go into deep sleep, then you'll go out of it and go into REM sleep, back into deep sleep. And eventually, as the night goes on and it gets closer to morning, you eventually go into lighter sleep and then you wake up. So, this process is really important. When you are in your deep sleep stage, this is actually when the body repairs itself. Your organs kind of fix themselves and get ready for the new day. and especially the brain. Tomorrow night, I'm going to be talking about, it's all in your head, and I'm going to be talking about dementia and Alzheimer's disease. But, one of the thoughts of scientists and researchers today is that, people who have Alzheimer's disease, they have certain specific characteristics in their brain where, I can't say that all Alzheimer's patients did not sleep well, but I will say that if you have good, deep sleep, that actually cleans out your brain and will decrease your risk of Alzheimer's disease. And I'll actually explain that a little bit more tomorrow. So does it matter when you sleep? You've probably heard that you should get as an adult, about 8 hours of sleep. Children need more than that. Children need sometimes, depending on the age, 10 hours of sleep or more. But adults generally need about 7 to 8 hours of sleep. But is it important, what time you sleep, as long as you get 8 hours or 7 hours? So I want to suggest that it is important to you. And generally, the recommendation, at least my recommendation, is that if you can get into bed somewhere between 9 and 10 p.m., that would be ideal. And let me give you some of my arguments for that. So if you go to bed earlier, and I know here we say 11 p.m., but generally I recommend if you can get into bed by 10 p.m., this is a good thing. But earlier sleep is associated with more deep sleep. And I'm actually hopefully going to show you a picture that most of your deep sleep occurs earlier in the night. A lot of your REM sleep occurs a little bit later in the night, but most of your deep, deep delta wave sleep occurs earlier in the evening. So the brain recovers, from the day's activities, and it actually, fixes itself while you're sleeping in this deep sleep. It's restorative sleep, and again, most of it happens early in the evening or early at nighttime as opposed to late at night. So let's now talk about melatonin. So melatonin, this is a great hormone. We need melatonin in our bodies to have proper sleep, and it contributes to so many other benefits in the body. Melatonin is a strong antioxidant, and as we've learned in our prior subjects and topics, we need antioxidants, right? Antioxidants help protect us against DNA damage, which helps protect our genes so we don't get cancer, we don't have increased risk of heart disease. So melatonin is a strong antioxidant. So we need melatonin for that reason. It actually can help you decrease symptoms of heartburn. It helps prevent migraine headaches. Those of you who have suffered from migraine headaches, you know that migraine headaches are very serious, very debilitating. And so it can help prevent and treat migraine headaches. Good melatonin production can actually help diabetes prevention. It can also help prevent cancer. Melatonin actually is a hormone that inhibits angiogenesis. And if you remember back to when we talked about cancer, we said that cancer needs angiogenesis, right? That was one of the requirements, which is new blood vessels to grow. So melatonin helps to inhibit that. It helps prevent macular degeneration. Macular degeneration is a process where you lose your eyesight because cells in your eye just degenerate. So it can help prevent these eye diseases, and it improves thyroid function. So melatonin, it's the very important sleep hormone, but has so many beneficial effects in the body. So how can we get enough melatonin? So one thing is, and I think if you think about this, this will make sense. You need to get good, bright sun exposure. You can get artificial light like we have here, but the best for good melatonin production is sunlight, like real sunlight, not artificial light. Now, I'm going to talk a little bit more about this in a few slides, but the other thing is, we live now in the true technological electronic age, and cell phones are everywhere. laptop computers and desktop computers are everywhere. We have giant TV screens. So, all of these emit certain types of light that can actually decrease your levels of melatonin. So we have to be careful how we use them. I'm not saying we shouldn't use them. It's almost difficult not to use these things, but we have to be careful how we use them. The other thing I would recommend to you is try to sleep in as dark a room as possible. When it's daytime, you want bright light, but when it is nighttime, you want to sleep in a dark room. You want to have that contrast so your body knows, this is nighttime and this is daytime. Now, I know some of you are saying, well, like if you have children, some children are afraid of the dark. Or you may be thinking, well, I have to get up to go to the bathroom in the middle of the night. I have to see where I'm going. I don't want to fall down. So I understand that. And some people need, night lights. And there are, better options even if you need to have a light in your room. So this didn't come out so well, but the recommendations are you should try to use a light that doesn't have a lot of blue light. And I'll explain that a little bit more later. But if you have a night light that is more yellow or orange or red, as far as light bulbs go, this is a little better to help preserve your melatonin levels in your body. So I know those are available, and I just want to make you aware of that. There are night lights that can be a little more friendly to your melatonin production at night. One thing you don't want to do, though, is, just turn on a regular light bulb. I have to say that I'm a little bit guilty of that sometimes. Sometimes I'm so tired after work, I go home, and I am in my bed reading something, and I'm so tired I fall asleep, and the next morning, the light was on all night. That's bad. Probably I made very little melatonin that night, so don't do that, please. Turn off your lights. The other thing is sleeping in a cool, well-ventilated room is important. It doesn't have to be very, very cold. You don't have to sleep in like a refrigerator type setting. But the optimal temperature for sleep, they found, is about 15 to 20 degrees Celsius, which is about 60 to 68 degrees Fahrenheit. So not warm, actually a little bit cooler. And if you are kind of sensitive to cold, wear blankets, But they say a cooler room is better for optimal sleep. The other thing they say is avoid EMFs. So EMFs are coming more and more into the news. EMFs are electromagnetic frequencies. So, even though they're invisible to our eyes, there are so many, electromagnetic frequencies around us. Just think of Wi-Fi, right? Wi-Fi is everywhere now, even though you cannot see it. But, if you look on your cell phone or your computer, you can see, how many Wi-Fi connections are in the area. Computers emit electromagnetic frequencies, cell phones, cell phone towers. I remember one time my parents were thinking about buying a house. The house itself was fine, but it was next to this huge electric tower, one of these electricity towers. And we just thought, no, this is not a good thing. So they didn't buy the house. But it's found that if you have too many electromagnetic frequencies around you where you are sleeping, this can also decrease your melatonin levels. So what foods boost melatonin levels? There are many. And the main thing I would say is if you eat a balanced diet, you should also be able to get some melatonin in your diet as well. So pineapples, bananas, oranges, oats, rice, corn, all of these have lots of melatonin. And this is just a picture of that. Now, I'm showing you this slide because I want to show you where melatonin comes from. And it's very interesting. You may have heard of the hormone serotonin. So serotonin is a hormone, a neurotransmitter in the brain. It's frequently called like the happiness hormone. And this hormone is found to be decreased in many people who have depression. And the common, how can I say, the common origin of these two hormones, melatonin and serotonin, is tryptophan. Tryptophan is an essential amino acid that our body needs. Essential meaning that our body does not make this amino acid, so we need to eat it in food sources. And a lot of good sources of tryptophan are found in plant foods. So, but I just wanted to show you this connection between serotonin and melatonin. You know, with your happiness hormone, you cannot be happy if you don't get enough sleep, right? So I wanted to also show you the circadian pattern of melatonin. You know, when is the level highest in the body? When does it start to rise? When does it start to go down? So here it is. So melatonin starts to, in the evening, start really producing it at about 2000. So this is about 8 p.m., right? It starts producing it, and then it peaks here at about 3 a.m. So one of my arguments to you about why you should sleep earlier rather than later is you want to get the full benefit of your melatonin. I'm not saying you have to go to sleep at 8 p.m. I mean, you can, and I would say that's not bad. But what I'm saying is you don't want to go to sleep too late and disrupt this nice rhythm here. If you go to sleep too late, you will not get the nice, healthy levels of melatonin as if you were to go to sleep, I would say, by about 9, 10 p.m. when it's really going up here. So you want to get the full benefit of melatonin, you should sleep early. So this illustration here just shows us that it's very interesting. So you have melatonin here in red, and then you have cortisol here in black. So cortisol is also a very important hormone in the body. It's most famously known as a stress hormone, but it's not a bad hormone. You know, we need cortisol in our body to have healthy function. And you can see they're kind of peak and have valleys at opposite times. And so this is very appropriate. You really don't want these to overlap at the same time. That would be very confusing for your body. Now this illustrates that just a common known biological fact that as you get older, so here your open triangle and open circle are elderly men and women. And so you can see these here on the bottom. So as you get older, your melatonin levels naturally decrease. And you know, when you're younger, you have higher levels of melatonin. So for those of you in the audience that are a little bit older, you know, this is another reason that you do want to get enough sleep to just get your full benefit of melatonin as much as possible so you don't miss out. But it is true that over time, melatonin levels tend to increase with age, or decrease, with age. Now let me skip this one. Now, I want to talk a little bit about blue light. Now, a blue light is a problem that is an emerging problem, again, because of the age we live in. We live in this technological age where, you know, almost everyone uses a computer or cell phone or some of our, you know, fancy large TV screens. So most of these types of devices use a certain kind of light source called LED, which is light emitting diodes, LED light. And when you look at LED light, it looks white. It doesn't look blue. You know, so this can be a little bit confusing. But within LED light, frequently there is a lot of blue light. You know, there's other different colors in there, but there is a lot of blue light. And the problem with blue light is it suppresses melatonin levels, which, as we know, is not good. And so if you have too much exposure to blue light, especially close to bedtime, it will, you know, affect and lower your melatonin levels. So one of the recommendations that's being given now is, you know, try to, if possible, 1 to 2 hours before bedtime, try to avoid too much interaction with your cell phone, you know, with your computer, or watching TV and things like that. You know, the recommendation is if you do that, hopefully you can preserve your normal melatonin levels in your body. And this schematic just kind of shows if you do have too much blue light, what can happen to your brain and body. So here it says it can affect your memory. It can be harder to learn, basically harder to concentrate. You can accumulate neurotoxins in the body. I'm going to talk more about this related to Alzheimer's disease tomorrow. It can lead to depression. It can contribute to obesity, eye problems like cataracts, and also increase your risk for cancer. So this is very serious, actually, how it affects multiple aspects of our health. So actually just a few months ago in June, so this is basically 2 months ago, the American Medical Association. So American Medical Association is probably the largest and most active medical association in the United States. And they actually put out a statement regarding blue light. They thought it was important enough that they said, we have to release this statement to the public. So many American communities are adopting more LED lighting, like for lights in the street, things like that. And sometimes lights in the government offices, etc. The reason they're doing that is it actually does save energy when you use LED lights. So the thought is, we can save money, save energy, and that's a good thing. Again, the problem though is that LED lights have a lot of blue light. And at least for street lights, we generally turn street lights on at nighttime, right? Not during the daytime. So if you live in a kind of a very urban area where, your home and where you sleep is exposed to these LED, street lights, then you could be at risk every night of, not getting enough melatonin. So the American Medical Association was cautioning communities to think about the health risks of, too many LED lights in their community. And they were saying that the blue light suppresses melatonin production, and LED lamps have 5 times greater impact on circadian rhythm than conventional street lights. So, this is, again, an emerging problem because of the age we live in, our technological age. Now, going on, I do want to talk about one other aspect of circadian rhythms. This is about eating. And again, in addition to sleeping, all of us eat, right? This is a essential function of life. So another question is, does it matter when we eat? As long as we eat, a few times a day. So there was a very interesting study that was done and recorded in the journal Cell Metabolism. And, the thoughts are this could have implications for human beings as well. So they took 392 mice, and they did something called TRF, or time-restricted feeding, which means that, they gave all these mice, these different groups of mice, the same food, but the only difference was that they restricted the time that they could eat. So in some cases, the food was only available to the mice for 9 hours, in a 24-hour day. In some cases, 12 hours out of the day, they were allowed to have food. And in other cases, 15 hours. So they looked to see, does this make any difference? It's the same type of food, but, for how long it's available make a difference? So this diagram just illustrates the results of the study. So let me try to go over this. So in the first group, you had obese mice, they're overweight, and they were eating, I don't really know if they're actually eating cheeseburgers, but they're eating a certain diet, the same diet. And here on top, ad libitum, this means that they could just eat whenever they wanted to. So this is kind of like the control group. They had access to food 24 hours a day, 7 days a week. So, the food, there was no restriction on food. So with these mice, they were obese, and then they became really obese, even more obese, morbidly obese. And then they had started with obese mice, and they restricted the time that they could eat. So, as we said, in some cases they could only eat for 7 hours a day or 9 hours a day or 12 hours a day. They had some time restriction. And interestingly, these mice, even though it was the same food, they were obese, but they were more fit. They were more healthy compared to these mice. Then they looked at mice who were lean, thin mice, and again, they had them eat the same diet. And in the top group, they said you can eat anytime you want. They had access to food 24 hours a day, and the lean mice became obese. Then they had the time restriction, and these mice still stayed lean, and they were fit, they were healthy. And then they said, okay, let's do another experiment, and this was kind of mimicking how human beings live, right? Which is, sometimes we can keep on a certain schedule during the week when we work or go to school, but a lot of times on the weekend, your schedule is different, right? If you're off and you're not working or you're not going to school. So this is what they did with the mice. So they had lean mice, and only on the weekdays, they time restricted their eating. But on the weekends, they just let them eat whenever they want. And they said, does that make any difference? And it was interesting. Even though 2 days out of the week, they ate whatever they wanted, they still stayed lean and they still stayed healthy. Now, I'm not saying that you can eat whatever you want on the weekend, but it just showed that this effect was preserved into the weekend. So, one of the implications for human beings, if humans follow similar patterns to these mice, is that when you eat does matter. It's not just what you eat, but when you eat also matters. And the thought is that if you can restrict the time you eat, you don't just eat any time of the day, you don't eat like very late, or you don't eat at irregular hours. This can actually have big implications for your weight and your fitness, how healthy you are. Now, to kind of wind down here, let me go here next. So I wanted to talk lastly about circaseptan rhythms. So as we said earlier, circa means approximately, septa is referring to 7. So there are actually a few examples, and scientists continue to discover more of 7-day rhythms in nature. So one of them that you know very well and that we've been hearing every night is musical rhythms. So 1 octave, if you are familiar with music, has 7 notes. The weekly cycle is 7 days, and this is recorded in the Bible as a command from God saying you can work 6 days, but on the 7th day you should rest. And even if it's harvest time, and in agricultural societies, harvest time was very important. You have to get the harvest done when it's ready. But God's command in Exodus was even in harvest time, you need to rest 1 day during the week. Let's see here. Okay, I think I skipped one. Yeah. So this slide I skipped over, but it's also very interesting, and actually even modern medicine has confirmed this. Before the nation of Israel existed, and Abraham, his family was growing, God told Abraham, he said, all baby boys, that's including, his servants, children, etc., that were born in his household should be circumcised after 7 days. And even in modern medicine today, in pediatrics, they have seen and they have confirmed that, after 7 days is when a baby's blood clotting factors are the highest in the body, and this is an ideal time to do circumcision. So prothrombin and vitamin K are factors in your blood that help your blood to clot. And so we see here that 7-day kind of peak time to do circumcision was documented even in the body, hundreds and hundreds of years ago. They've also found that if you have a patient who has kidney problems, renal transplant rejection is likely to occur more frequently in a 7-day cycle. So 7 days after you have had a transplant of a kidney, it's more likely that you will have rejection. And they've also found 7 days and then 14 days later. And they don't actually know the reason why that is, but they have been able to document that it kind of occurs predictably at 7 days and at 14 days. So to end here, I just wanted to bring to your attention some ideas about time. When we think about time, we usually think about the common concept of time called chronos. Chronos means time measured as we understand it, in seconds, minutes, hours, days, and weeks. But the ancient Greeks also had another term for time, and that was kairos. And kairos referred to a special kind of time. It was like the right opportunity time, the fullness of time. And so the one thing I want to, as I close tonight, leave you with is, as you've been hearing different discussions about different health topics, I want you to think in your mind, like, this is the right time for you. This is the right time for me to do something about our health. I think all of us, including myself, can make changes to improve your health. So this is your opportunity as you learn more information. Hopefully that motivates you to make improved changes in your health. As we talked about on earlier nights, we know that our body is the temple of the Holy Ghost. And God made our bodies in such a way to glorify Him. So I want to challenge you and encourage you tonight to think about this and think that, this is my opportunity. This is the time. Now is the time for me to make positive changes in my health so that I can glorify God. So tomorrow night, as I mentioned, I'm going to be talking about It's All in Your Head, and I will be discussing the topic of Alzheimer's disease. I will be delighted if you can join me. Thank you very much.
Coming Broadcasting Network.